Can I start? Can I start? Can I start the presentation?
Yeah, we can start.
So, Namaskar all. This is Geethika of AI second year. So, today I'm going to give a small presentation on the topic Introductory Reciprocation of Internet. So, here is the agenda of this presentation. Firstly, I'll discussing how the Internet facilitates the movement of data packets. And protocol, followed by how DNS lookups work, and then email exchange works using SMTP and IMAP, followed by how network ports and firewalls work, and finally differences between hardware firewalls and software firewalls. Well, before we can venture into the world of web development, it's important to have a fundamental understanding of how the internet works, meaning what's happening behind the scenes. To think of it in simplest terms, the internet is a network of cables that facilitates the transmission of data packets. And this network of cables is extremely vast and spreads globally across 550,000 cables under the ocean. To keep the world connected, the snapshot provides a graphical illustration of how complex the internet really is. So basically, a data packet contains the information being transmitted, such as an email file or a web page in raw text format, and also the location of the sender and the recipient of the data packet. You can think of the location of the recipient as a physical residence or a phone number. So basically, no two residences have the same address and no two people will have the same phone number, right? The same is true for internet addresses, also known as IP address. So this IP address is a string of numbers separated by periods that identifies each computer and that is connected to network or internet. For example, Google.com web server has an IP address of 74.125.224.72. So each website will be having its own unique IP address. So now let's take a look at an example of email data packet. As we can see here, the data packet consists of three parts: header, payload, and trailer. So this header identifies the sender and receives the IP address. This payload indicates the actual mail that is being transmitted. And lastly, trailer indicates the package is complete and there is no further data for transmission. The speed at which these data packets can be transmitted over a network is determined by bandwidth. This is the amount of time it takes for one bit to be sent from sender to the receiver. So let's take an example. See, like if you want to send a 4 MB MP3 file to your friend through an email attachment in 4 seconds, then you would require a bit of 8 megabytes per second. This is because 8 million bits is equal to 1 megabyte. It goes without saying that the internet is comprised of hundreds of thousands of networks and links billions of devices together globally with this level of connectivity. You might be wondering like how each individual network device can efficient and accurately interpret and read the data from unique servers. Well, you can think the internet as an architecture expressed in a set of protocols. So what is this protocol? This protocol is a well-established set of rules and standards used to communicate between the machines. We have already touched on one protocol, that is the IP. This IP is used to read the information to the proper address and make sure that the data packets are sent to the intended recipient. We have to note that this IP protocol does not facilitate physical connections between data packets. For that purpose, TTP protocol is intended. TTP protocol makes sure that the transmit data packets are received without any missing information. If it is determined that the data packet is missing, then DCP will request other protocols. This HTTP and HTTPS are very relevant to our presentation. These protocols define how your internet browser communicates with the web server to display your website. We have to keep in mind that the web page and its contents are transmitted in the form of data packets just like any other type of file. we can think of a web server as a computer that hosts a website or a web application, and it is configured to accept remote connections with internet users. So HTTP stands for Hypertext Transfer Protocol, and HTTPS stands for Hypertext Transfer Protocol Secure. So let's start with HTTP. See, like when we type a web address into our web browser, so for example, www.google.com, our modem communicates with our internet service provider. It will ask to translate the web address into numerical IP address. This is done through DNS domain name server. These are administered by our ISP or internet service provider. This domain name server is a list of domain names and their corresponding IP addresses. Sometimes our ISP may not be able to locate the IP in their DNS records. At this point, your ISP would take a step further and query about authoritative DNS servers for the IP. And once the IP is found, it sends this data back to your web browser. Your web browser then gets a GET request to the IP address. If the request is successful, then the contents of the web page are delivered. And this GET request looks in this format. And if the request is successful, then HTML page will be displayed. And coming to HTTPS protocol, this is more secure method of data transmission than the HTTP protocol. In this, the data packets that transfer back and forth between your browser and the website server are not encrypted with the standard HTTP protocol. This means they will be in plain text, and if they are intercepted by an intruder, all the information would be readily visible. But with HTTPS, all the data packets are encrypted using SSL or secure socket layer. So an SSL layer can be created by installing a security certificate on the web server that hosts the website. A security certificate can be purchased from a reputable vendor, which will verify information about the domain and the registrant. Process and so prior to issuance, so yeah, and moving ahead to SMTP server. So this is a quite complex when it is so when it exceeds thousands of subscribers, this SMTP will become yeah. So SMTP or Simple Mail Transfer Protocol is another protocol that you will almost certainly encounter as a web developer after your web application has been developed. So you will need to communicate with your customers through email management setup. So this can be more complex when you exceed thousands of subscribers. At that time, this SMTP comes into use. So this SMTP protocol will be having two scenarios like local mail delivery and then outbound mail delivery. In local mail delivery, firstly, the sender and the receiver are exchanging emails or originating from the same domain. So if you see here, jane at gmail.com is sending to joe at gmail.com. Like the origin is same. Whereas in outbound mail delivery, jane at gmail.com is sending mail to bob at yahoo.com. So the domains will be different. Depending on the type of email exchange, the path to delivery will be quite different. So it varies with that. So yeah. Now we can take a look at the mechanisms that allow or restrict the movement of these packets using network routers, firewalls, import configurations. We'll start with local area networks. A local area network is best described as a group of computers that share a common communication line within a small area. A LAN is typically confined to a single room, building, or group of buildings. So this LAN is formed in some important configurations to illustrate the structure of local area network. We'll start with the most basic network configuration. See, when we first sign up for internet access with our local ISP, the ISP issues us a modem. This modem is connected to our ISP using a coaxial cable or DSL phone line. This cable connection allows us to transmit the data packets over the internet as we learned earlier. So technically, we can now take a computer and connect it directly to the modem using an Ethernet cable. In this case, IP address assigned to the modem by our ISP would resolve directly to our computer. Actually, this is a great start, but it has some issues also. So by connecting the modem to a router, all devices connected to the router can access the modem and therefore the internet. The router provides a local unique IP address to each connected device so that they would still have the same external or public IP. That router would then analyze all data packets traveling through the network and direct them to appropriate location, whether within the LAN or destined for the internet. So when John sends the email, the router directs the email to the wide area network for outbound delivery. It also sends a print job to a printer attached to a network through the router. This router knows how to keep the data packets associated with the print job within the local area network. So now that we have a better understanding of local area network and wide area network and the role of network, so now let's explore the basic security configuration. In the previous slide, we introduced the role of router in setting up a network. And now let's see network ports. So a network port within the context of internet can be thought of as a data pipeline that is configured on your network router. So ports can be open or closed to allow or restrict the movements of data packets associated with various protocols. Port numbers are assigned a numerical value when created. For example, like if you take port 80, it generally handles incoming and outgoing data requests transmitted through HTTP viewing and hosting web pages. And if you take port number 25, it handles data transmitted through SMTP for sending emails. And if you consider port number 21, it is used for exchanging files over the file transfer protocol. These are known as hardware firewalls and are very effective in protecting your network security. So a firewall is a system designed to prevent unauthorized access to or from a network. They can be customized to meet your network needs. In addition to that, a hardware firewall, a software firewall can also be added for an additional layer of security. Most of the operating systems come with built-in software firewalls such as Windows Firewall, etc. A software firewall prevents the data packets containing malicious content from entering your network. And this type of firewall can be installed on your computer if there isn't one present already. So firewall configurations can block certain ports from transmitting data or block specified applications from transmitting data packets. In this illustration, we can see that firewall on this computer does not allow the applications type ICY or vibrate to communicate with the internet. If the user attempts to transmit data packets through these applications, they'll be blocked by the system's software firewall. So if we see the second example, the second computer has no firewall. The user is attempting to send an email to Bob using SMTP port number 25. So the email data packet successfully travels past the router and through the modem to the sender's ISP. This ISP successfully delivers the message to Bob's email server. And if you see, Bob is at work in attempting to connect to his email service provider. To check his email, he doesn't realize that his employer has blocked point 110, the default port for incoming mail over POP3. As a result, he is unable to receive his email messages. We have to note that software firewalls are not as effective as hardware firewalls. Much of the effectiveness of the software firewall depends on the overall configuration of your operating system and all the applications that are installed. Sometimes downloading a Trojan or a virus by mistake can open a backdoor into your network, leaving the software firewall meaningless in the line of defense. Whereas coming to hardware firewall, on the other hand, it is not as vulnerable because it is not affected by security threats installed on a computer within the local area network. So, yeah, thank you for patiently listening.